Hello, and welcome along to this video where we are going to be looking at the different options that I, or you as a maintainer of an open source project, have when it comes to providing feedback on or uh, continuing work on a pull request that's come into your repository. So let's go ahead and jump in. So I've got a fairly contrived example here, but essentially what I've got here under my, I've got a repository here just called GitHub tests, and it has the simplest of simple .NET Core console application. So what I want to be able to do is I obviously want to create new features, add new features to this bit of code, and hopefully other people in the community is going to help out, and they're going to create a pull request to enhance that functionality. So what do I do as a maintainer when it comes to making that possible? So in terms of this example, what I've got here is I've created an issue. So I've said I want to add a new super duper function to this bit of code. So obviously, like I say, it's a contrived example, but stick with me here, okay? So ignore this closed pull request that's being shown here. That was my testing before I did this. But what we can see further down is that my friend and open source contributor, Kim, Admiring Worm, he's created a pull request into this repository to provide this new super duper function. So GitHub makes this really simple in terms of knowing that there's a pull request linked to this issue. And that's possible because of the way that Kim created the pull request. So let's take a look at the pull request and we'll see how that's happened. So what Kim did when he created the pull request is he added this nomenclature, which is fixes and then the #1. So that's a link back to the issue. So what GitHub's done is it's linked this pull request to that issue. Now, if Kim hadn't done that, there is an option within GitHub itself to link to a specific issue. So if you don't use that nomenclature within the text of the pull request, then you can manually browse to it and then link that issue if you need to. But in terms of what Kim has added to this, so again, contrived example, but let's look at the files that have changed. So we'll see here that Kim has added a line that is added the super duper function. So obviously, if it was a proper bit of code, it'll be functions added to do stuff, etc. But what's happening here is that straight away, GitHub, because GitHub has all this built-in functionality, and because I've added a GitHub action into this repository, it's telling me that there's a problem with this PR. So that there's a missing semicolon at the end here. So from a C# compilation perspective, this code won't work. And I also see that there's another issue here where the console hasn't been, there's a missing E on the end of console. So there's a couple of issues there. But from the outset, from looking at this, Kim's done pretty much everything that I wanted to do to close off that issue. So if we look at the commit, again, he's used a sensible commit message. He's linked using additional nomenclature, the GH-1, so that this commit is linked to that issue. So all of these, aside from the fact that the code doesn't compile, this PR looks good to me. So I want to be able to pull this in. I want to bring it into my repository so that we can continue work on other pieces of functionality. So the problem that we have now is, well, how do we address this pull request? Do we, so there's a couple of options. The first thing that I could do is I could go into the file here and I can click on this and I could add a suggestion here. So one of the things that GitHub makes really simple is that I can insert a suggestion. So I could actually say, in line in this comment, I could change this to say console and I could put in a semicolon here. And I could say start a review. And then I could say, so the way that GitHub pull request reviews is you can do single comments on each line, or you can do a collection of comments and do it as a single review. So depending on whether you want to flood the contributor with information, or whether you want to do it as a single notification to say that a pull request review was submitted, I prefer the latter. So if there were other lines in here I wanted to comment on or make suggestions on, then I would definitely do that. So then I can say finish review, and I could say request changes, and I could say, let's make a comment here and we'll say, thanks for submitting this, just a slight problem that needs to be addressed. So I could say submit review. And at that point, what would happen is that this suggestion is being made, and what Kim could do is Kim could click on the button on his side that says, oh, that's a good suggestion, how about we fix it? Now, that is obviously one way of doing this. That level of interaction backwards and forwards would result in a PR that then goes through the continuous integration build that I've set up. It would hopefully come back with a successful build, and then we could move forward. Now, and that's great, but it could be that this thing that's being added here is something that needs to be merged then quite quickly. So Kim might live in another time zone from me, so I might want to say, well, I want to pull this in now, rather than waiting for Kim to come back to me and updating the PR. So what GitHub also does is GitHub provides additional information. So, well, let's backstep. GitHub also has the ability of me saying, well, I could just merge this request. I can merge it as is, and then I could fix the problems that there are on the PR, and then I could contribute that back into my GitHub repository directly. Now, the problem with that is then we lose the benefit of the continuous integration that we have, because at that point it wouldn't be doing a continuous integration build on what's in the PR branch. It would be doing it directly on what is the target branch, the master branch in this case. Now, the problem with that is there might be other underlying issues that we don't know about. So ideally, we want to do all the continuous integration build on the PR branch. That way, if there are further issues or further changes, we do that without affecting anybody else that's working off of the main branch. So there's a good reason to work on that PR branch, the one that Kim's using. Now, there are command line options here, so there are options on how I could bring all of the changes that Kim has put into that PR onto my machine, and then I could continue working on it. The problem with that approach, though, is that I wouldn't be working on Kim's PR branch. So again, it bypasses the continuous integration build. Now, the way that I have gotten around this in the past is I have updated my local copy to include a reference to Kim's copy of my repository. And that sounds a little bit complicated, and we're getting into the realms of what Git is in terms of a distributed version control system. But let's walk through that process a little bit and see if we can put all these pieces together. So at the command line here, if I do a command that is git remote -v, it tells me all the current remotes that I have for this repository. Basically, what is the original repository that I've cloned locally onto my machine here. So at the minute, Git is telling me that the only remote that I have is to the original source location for that repository. So this URL, get13oss GitHub tests, is the only remote that I have. But there's nothing to stop us adding additional remotes. So what I tend to do on a PR, if I want to provide changes back to the repository that it came from, I would do the following. So I would right-click and open a new tab on this one. So this gets me to Kim's clone or fork of my repository. And what I can do is I can grab this URL here, which is the URL to Kim's copy of my repository. So if I go down here and I do a git remote add, and I typically name it as admiring, I name it with the name of the person that it's come from, and then I can put that in there. Okay. So what that does, if I do the git remote -v again, I can now see that I have got another copy or another pointer to a version of this repository. Now, those two are currently out of sync because Kim's done some work in a branch on his copy that doesn't exist in my copy. So what I can do to bring those changes down into my one is I can do a git fetch from admiring worm. Okay, so what that's going to do, it doesn't change anything on the file system. It just brings that information down into my clone of the repository. So what we're seeing here is that it's now got information about a feature branch that it lives on Kim's copy. Okay, so if I were to do a git checkout onto that feature branch, right, and I look at that now, we can see that I've now got Kim's changes. These are the changes that we were looking at in the pull request through GitHub user interface, but I've now got this information on my machine. So I have the option of starting to fix these issues. So if I were to put that semicolon in there, I then have the option of creating a commit and pushing that back now into Kim's copy of the repository. So that's possible only because of the way that Kim created the pull request. So back here, if we look down here, GitHub is telling us that we are capable, it's possible for us to add more commits into that featured GH1 branch, and that's the default. So every time you create a pull request in GitHub, default is to allow the maintainers of the repository that you're pushing into to also push changes back into your fork of the repository into that branch. Now, that doesn't give me full access to Kim's repository here, because that would be bad, obviously. But what it does do is it allows me to add commits into his copy of my repository into the branch that he created. So I'm going to leave the other issue with the console not being quite right for the next part of this video. But what I can do here is I can add another commit. So I'm going to say gh-1 add missing semicolon. Okay, so I'm going to commit this. That's just telling me I haven't staged it, so I'm just going to say yes to that. So now, on my copy, if I look in Git extensions, so Git extensions just gives me a kind of a visual representation of what's going on in my repository. It's completely free. You can get it quite easily. But what this is telling me is that now, on the Admiring Worm feature gh-1 branch, I've now added another commit that fixes the missing semicolon. So now, having added that remote, having checked out that branch locally onto my machine, I can now do a git push, and I'm going to be explicit. I'm going to say that I'm going to push this into my Admiring Worm remote. I'm going to do a git push of that commit back into what is Kim's fork of my repository and into that branch. So what we'll see happen on the PR, if we go back to the PR now, what we should see is that things are starting to change. So rather than having just one commit, which is the commit that Kim added, we've now added in a second commit. And that second commit is me adding in that missing semicolon. So we are now contributing back, working through that process of getting things working. So Kim's done the original upfront work. I've maybe found a potential problem with it, and I'm trying to help him fix it. So rather than going through the suggestion workflow that we've shown that we can do here, I'm directly adding commits into his branch. So this is a great way of helping a new contributor to a project by providing some guidance and adding commits directly into those. And because we're doing it in such a way that we're doing additional commits, they can then have the option of pulling those commits locally into their copy to continue the work again. So it's a great kind of workflow that happens, and I, as a maintainer, have some control over that. And like I say, this is all possible because of the fact that when Kim created the PR, he left the default option, which is for a maintainer of the project to push changes back again. However, the little workflow that I went through there, so if I do git checkout and I go back to the master branch that I've got here, that little workflow that I had to go through it's a little bit convoluted. I had to find the remote, the URL to the remote that is Kim's repository. I had to add that remote, I had to fetch, and then I had to check out. It's a little bit convoluted. So for now, I'm going to remove that remote that I created. So I'm going to go back and put this back to the way it was. So if I do a git remote -v now, I've only got my original one now again. And if I do a git branch, just to list out the branches that I've got, I'm going to go ahead and I'm going to delete that feature branch that I've got, because I want to get back to a point where I can do what I did, but do it in a slightly easier way. Now, the reason it's telling me that I can't delete the branch is because Git knows that the work that's been done on that branch hasn't been merged into the master branch currently. So it's telling me that only delete the branch if you're really sure about what you're doing. So in that case, you change the lowercase d to a capital D. So at that point, I'm going to say, so Git is trying to protect us here, but I'm going to say that actually, I really know what I'm doing. So I'm going to delete that branch. So I'm going back to I'm now back to a place where I've only got my single master branch and I don't have that remote that I created before. But what I've got instead is I have a tool installed, which is the GitHub CLI, and I can make use of that just via the gh command. Now, I got this onto my machine by doing choco install gh, so choco, the choco exe, or the chocolatey application is a Windows package manager that helps with the installation of tools. So all I did was choco install gh, and what that gave me is this little tool that is, you can scroll up here, it says work seamlessly with GitHub from the command line. So what this lets me do, for example, let's just clear this out. I can run gh here with PR command and then list. And what this allows me to do is this allows me to list out the PRs that are currently open on the repository that I'm in currently. So the GitHub CLI knows that I'm in a Git repository. It obviously knows the remote URL to where that is located. And using that, it can run commands like this to tell me what are the currently open PRs. Now, what I can then do, if I run ghpr-help, it'll then tell me what additional commands are possible. So I could close a PR, I can create a PR, I can merge a PR. Lots of things I can do through the user interface I can now be done at the command line. Now, the one that I want to talk about here is this one, checkout. Check out a pull request in Git. So that workflow that I did before, which was to create a remote, to fetch that information down into my local Git to then check out that branch, I can use the checkout command to do that, and it's much simpler. So if I can now do GHPR, and I need to give it a number. So the number in this case is the number of the pull request. So the pull request number, I can see it in the URL just behind here, is that it's the number 3 PR, and I can see that from the list. So in the list command, it's telling me it's number 3 there. So if I do git pr checkout number 3, what that's going to do, and this is the magic part, it's moved me onto that feature gh1 branch that Kim created, and it's also done the important part, which is to create a Git reference back to where that PR branch lives, and that's the important part. So this is replacing that work that I did of creating the remote, fetching it, and checking it out in a single command now with the command line. I'm now on that branch with all the changes that Kim created originally and the commit that I've added into it. I'm now on that branch locally on my machine. So if we go back into Visual Studio Code, we can see that it's currently up to date in the sense that it's got that extra semicolon that I added in that commit, but it's also still got the change when it needs to change the name of the console. So if I make that change, then again, I've now got a change to Git that I can commit back. So if I add the nomenclature that is gh1 again, and I'm going to say fix build error, okay? So I'm going to make that commit. I'll just show checking that in properly. So I'm going to stage that change locally with the plus sign, and then I'm going to hit the commit button, so it's going to commit that change. So now the interesting thing here is I can just do a git push, okay? So now I'm going to do a git push, and it's going to take the commit that I just did, and it's going to push it up into the feature gh1 branch on Kim's repository, okay? So now if I go back to GitHub user interface, it's now going to change again. So this PR now knows that it has the original. I'll need to refresh that. It's not going to come through. It's got the original commit from Kim. It's got the second commit that I put in, which was to add the semicolon, and now it's got a third commit, which is to fix the build error. So now, as a result of that, I'm now going to get the benefit of the CI process that I have in place, the continuous integration build that I have in place. I now get the full benefit to know that all of the work contained within this PR now has a successful build. Now that build at the minute, it's, if we go up here and look at it, so if I go into code folder and then in workflows, and then look in my .NET Core YAML file here, we'll see that all it's doing is it's running .NET build. You can't really see the bottom of that because of my head, but let's try and make it so that we can see all of that. So it's got a .NET Core build, and it's also got a .NET Core test. Now my project at the minute doesn't have any tests in it. Okay, again, it's a contrived example, but if there were any failures in the unit test that I had in my project, then the benefit of making the change directly into the PR branch that Kim created means that this pull request would still fail the build. So I get the immediate benefit, the immediate closing of that loop that says this has failed the build. Okay, so rather than me merging it directly or and then making the changes locally to then push back up, or making the suggestion and then having that time gap between those things happening or being resolved, the benefit here is I can add the commits directly into the original PR branch. So Kim will be able to pull those down locally onto his machine and continue the work, but I'm adding things to it. I'm not breaking anything from Kim's point of view. Now, the thing that I'm going to do next, it will break Kim, okay? But it's also part of the workflow that I, as a maintainer, happen to adhere to. But this, again, this is my decision. You don't have to do this part. So the final part that I'm going to do is that currently I have 3 commits into this PR. The original one that added the super duper function, the one that added the semicolon, and the one that fixed the build. Now, to me, these 3 commits should really be resolved into one because they're all related to the adding of the super duper function. These additional commits here are just the means to an end to get to the point that we wanted to get to. So depending on which side of the equation that you fall on, you're either going to like these additional commits or you want to squash them. So I want a logical commit that has all of the work that went into adding that super duper function. So what I'm going to do now is I'm going to use the rebase command, and I'm going to do that interactively. So I'm going to do git rebase -I on the master branch. So what I'm going to have the ability to do now is I'm going to have the ability to make changes to say that, okay, the command that I'm adding in there is F. So we can look at that to see what that's going to do. So F, or fix up, is going to, it's like squash. So the squash command is use commit but meld into the previous commit. But fix up is like squash, but it discards this commit's log message. And that's exactly what I want to do. So the log message that I added was added missing semicolon. So I'm going to take this commit, which is shown by the commit SHA there, is I'm going to take this and merge it with the previous one, or meld it with the previous one, and discard the message. And I'm just going to leave the message as added super duper function. And I'm going to do the exact same thing with the third commit. So I'm going to say fix up here. I'm going to meld it into the previous commit and discard the commit message. So I'm going to say save that. And what that will then do, I'm going to save that and close it. And what that will do is then it's then going to rebase those changes. So it's then going to say that's been completed successfully. So now if I look in Git extensions, what we should see, let's just make sure, is rather than having 3 commits, I've now got 1. And that single commit, if we look at what's been added, the only change now is we fixed the missing E at the end of console, and we've got the semicolon at the end. And the other slight difference, if we look at the commit, is that the author of the commit is at Miring Worm, is Kim, but the committer has now changed to be me. So the act of doing that rebase operation has changed some of the properties of that commit. So before, if we'd looked at this commit before, we would have seen that Kim was both the author and the committer of this commit. But the act of rebasing has changed it to leave Kim as the author, so he's still going to get the internet points, the kudos for being the author of the commit. But because of that operation, I've changed it to be I'm the committer. Okay. Now, if I were to try and do a push here, I suspect that this is going to fail. So I'm going to try to do a push against the reference that we have to Kim's branch. Now it's going to tell me that it can't do that. And the reason it can't do that is because I've done what's known as I've rewritten the history of that commit into that repository. So there's a disconnect now between the logical history that is in Kim's copy of the repository in the branch and what I've now got in my copy. Now what I can do is I could actually do a git push -f. And that's a force operation. Now, the git push force is something that does have ramifications, and you have to use this sparingly. Okay, you should never do a git push -f on what is the main branch, the master branch of the repository. Doing that will potentially break lots of people who have got forks and clones of your repository. So you would never want to do that on the main branch, the public branch. But because we're in a feature branch here, so Kim also did what I kind of expected from a contributor to a project, is they've done all the work on a separate branch. So because we're not on the main branch, the default branch, we have the opportunity to make changes to it. So doing git push -f in this scenario makes sense. So essentially what's going to happen, if I run that command, it's going to rewrite the history of the commits into that branch on Kim's version. Now, that does have connotations for Kim. So his branch checked out locally on his machine is now out of sync. Now, there's ways to get around that. So this operation should, again, only be done by communicating with the contributor who's going back into your project. I'm going to say git push -f and force my changes onto Kim's branch. But what will happen now if I refresh this page is that we've now got, in my PR, I've now got a single commit, and you'll notice that again, before it just had Kim's head in the commit. Now it's got my head as well in terms of being the committer. So assuming that this goes through, we're now in a position, so I'm going to wait for the PR to succeed, and it has, the PR build to succeed, and it has. We're now in a position where we've looked at the PR that came from an outside contributor to the project. We've identified that there were some issues with it. We could have gone down the route of making a suggestion and having Kim change it and then have him update the PR, but there's a time lag there. So in this scenario, I wanted to get this in as soon as possible. So I've used a couple of different ways of getting Kim's branch onto my local machine so I can make changes. And by pushing them back into that ref to Kim's repository, we then get the benefit of the CI build running and knowing that we haven't broken anything else. So this to me is the best way of getting those contributions into your repository. You want to accept and you want to attribute the person who's doing the work, but you also want to make slight tweaks to it. So depending on how you work, doing the slight tweaks in this workflow means that we can then merge knowing that it's going to work. So I'm just going to go ahead and say that I'm happy with, I'm now going to say that I'm now happy with the changes because I've done that. And so this is now going to be marked as outdated, and we can say resolve conversation here because we've taken care of it. So we're now in a position where this PR is good to go. So I'm going to say merge pull request here. And then I'm going to say confirm merge. And then the final thing that we need to do there is probably the most important part. So now that that has been merged successfully, we need to say thank you. Okay, as a maintainer of an open source project, someone has gone out of their way to improve our project. We need to make sure that we thank them for it. So we say thank you very much for your contribution. Really appreciate it. Okay, I'm going to go ahead and say comment here, And the final thing that we want to look at is the other thing that GitHub's going to do for you automatically. So because Kim in the original message that he added said fixes number 1, if we now go back to number 1, the issue, GitHub has now closed that for us. So because we merged this PR, GitHub has looked at the linked issue and said because of the action of this PR, it mentioned that it fixes it, and it automatically closed this for us. So GitHub is helping us in that scenario as well. So I hope that this is useful. I'm intrigued to see if there are any other ways of doing things like this. So if there are, feel free to reach out in the comments below. I need to go and read a little bit more on the force with lease because that's not doing, or I don't understand how that works. And like I say, I tried to be clever and say that you should really use this when you're doing this, and I don't actually use it myself. I just do a git push -f, but I do understand the ramifications of doing that. So I would encourage you to read up a little bit more on force with lease to make sure that you're doing that properly. And I'm going to go and do that just now. But for now, that's all I have. I hope this was useful. Like I say, any comments, feel free to reach out in the comments below or reach out on Twitter. And happy open source. Thank you very much.